Okay, we're going to go ahead and get started. I want to thank everyone for taking some time out of their day to learn a little bit about Huawei. This is a very interesting topic today. This is a lead-in to our participation at VMworld next week, and one of our experts in the area is going to be our main presenter today, which is exciting. The topic is streamlining data center operations and provisioning with Huawei nCenter in VMware. Our speaker today is going to be Ian Fu. He's the Director of Data Center Products and Solutions, one of the foremost experts in this space, which is really fantastic, and we appreciate having Ian a part of this. Throughout the presentation, we are going to ask a few polling questions, so we really appreciate your participation on those. And then, as always, Ian loves to try to be stumped, so if you have some questions that you can ask in the Q&A section of your GoToWebinar interface, please do so, because Ian wants to try to get the hardest possible questions and see if anybody can stump him regarding what we're doing on this topic. So without further ado, I'm going to turn it over to Ian Fu. Thanks, Ian.
Great, thank you. Thank you for joining us today. So again, the topic for today is learning how to streamline data center operations by leveraging Huawei's nCenter platform in conjunction with a VMware virtualization environment. A quick look at our agenda for today. From the beginning, we'll take a quick look at the virtualization market landscape and discuss virtualization platforms in generality. But the focus for most of the presentation is going to be the integration of Huawei's cloud fabric network infrastructure architecture, or data center network infrastructures, with VMware hypervisor virtualization environments, specifically the vSphere platform. We're also going to take a quick look at virtualized workload integration into the network, why we're trying to do this, what the benefits are of doing so, and then more specifically Huawei's nCenter solution for providing virtualized workload integration into the network infrastructure. I'll conclude the session with a quick discussion of a simple case study regarding a customer we have, and we'll discuss Huawei's presence at VMworld USA 2014 next week in San Francisco. Let's take a quick look at the server virtualization landscape. Let's start with a quick look at hypervisor market shares. If we look at virtualization in general, across the board today, approximately 65% of enterprise workloads are virtualized, and that number might vary a little bit depending on research firm or analyst you talk to, but that's a good approximation of the amount of workloads that are virtualized. Typically, the workloads that are virtualized are the less resource-intensive workloads or less CPU-intensive workloads, things like email servers, DNS servers, DHCP servers, support services, and applications that don't tend to have a high utilization rate on a compute platform. Again, the main goal in virtualizing is being able to consolidate these workloads to increase and maximize the efficiency usage of a given hardware server platform. And the savings in this space and in this respect in being able to maximize a given physical platform can be fairly significant when leveraging hypervisors or virtualization. If we look at the hypervisor market share across the industry, VMware still holds the lion's share of that market at approximately 52%. And we're seeing across the market a growth in Microsoft Hyper-V, but again, the dominance is still held by by VMware and their vSphere platform for virtualization. So let's take a quick look at the many benefits of server virtualization. Why is the industry moving this way? As many of you already know, since you're living the virtualization environment, the goal here is to maximize resource utilization by consolidating workloads to increase overall utilization of a given platform. One of the other benefits in being able to virtualize a workload is disaster recovery. By being able to package and image an application in a virtualized container, we can now move that container or replicate that container across resources or across facilities to provide some form of disaster recovery. Another point of being able to containerize an application into a virtual workload is the simplified application replication and deployment aspect of it. Now, if we have an application that we need to replicate, we can take that virtualized workload, clone it, copy it, and redeploy it as an adjunct in scaling that particular service. And one of the nice things about it is by having these predefined templates or virtual machine packages, if you will, or applications, we can now deliver an application or service with reduced complexity and time to deliver that application in terms of deployment, provisioning, or movement. And these are fairly obvious benefits, and I think that this is why we've seen massive growth in the virtualization market over the last 5 years. For the rest of the presentation, one of the things we're going to focus on heavily is reducing the complexity and time for application deployment by leveraging virtualization. And the reason we're going to focus on this particular area is because this is where the tie-in to the network becomes critical. Until now, compute and storage resources have been largely isolated or siloed in their provisioning and management from the network infrastructure when it comes to deploying workloads. When we look into the typical enterprise data center, the three main primary resources that we're going to be allocating in terms of deploying a new application in a virtualized environment are going to be compute, storage, and the connectivity for that virtualized workload. And that connectivity has been truly the missing link to really consolidating and closing that gap to be able to realize true cloud computing and honestly reduce complexity and time for application deployment. So based on this high-level overview of the virtualization market landscape, we have a question for you. And just to get a little bit of feedback from our audience and see where our audience stands, it's time for polling question number 1.
Thanks, Ian. Let's go ahead and launch that poll. So what we want to know right off the bat here is what virtualization platforms are you currently leveraging? And we say platforms because this is a multi-answer capability, so you can choose more than one, but we want to know kind of what are you using today. We appreciate everybody's participation in voting. If you're using VMware and Hyper-V and Zen, KVM, any of these are available, so just let us know. And we'll take just a few seconds here to let you vote. While you're voting, we just want everyone to know that we are also very eager to get your questions, so just go ahead and type your questions into the Q&A panel on your GoToWebinar interface, and Ian will be answering all those at the end of the presentation. So we'll give you a few more seconds to vote. We really appreciate everybody's participation today. We want to try to get as many votes as we can, so please vote. Okay, let's go ahead and share the results. And it doesn't look like we have a whole lot of guys on the open source platform, but we've got obviously VMware, which we'd expect, Ian, and also pretty good representation for Citrix Zen, Hyper-V shows, and a few guys aren't using virtualization. So hopefully that's helpful, and we'll turn it back over to you, Ian.
Great, thanks. And thanks for the feedback from the audience. So in the second section, let's take a quick look at the idea of virtualized workload or VM integration into the network, or what's also known as VM awareness in the industry. And let's talk about why we want to do this and what it provides in terms of benefits. So why are we doing this? What is the goal of VM integration and awareness? And the following goal is really what I try to convey as the goal around this effort. And really, what it is it's an effort to enable the network to be provisioned and managed as a unified resource pool, but cohesively at the same time with compute and storage resources within a virtualized cloud environment. Meaning that when compute and storage resources are allocated, that the mechanisms are put in place to allow the network to allocate policies, bandwidth, and logical topology of the network to accommodate that application in conjunction with compute and storage resources. And if this is done correctly, if we pursue this goal and we do it correctly, what this gives us is it gives us a level of automation in the network that brings us closer to having a software-defined data center, allowing the network to logically redefine itself in order to meet the requirements of the applications being run on it. And also, that level of automation, if done correctly, brings the enterprise closer to a true cloud-based self-service deployment model where we can begin to automate deployment of applications and give the end users or the developers control of being able to deploy those applications and have the network automatically provision itself, thereby lessening some of the siloed processes that are typically required in order to do that. If you look at it today, with platforms such as vSphere from VMware, we can automate the deployment of compute and storage, and loosely automate the deployment of networks. Because we have these underlying physical networks that have been in place for a while, typically those are managed by different groups, are managed slightly differently, and are managed in a siloed manner that require a separate parallel process. When you begin stacking these parallel processes, you introduce time needed to deploy these services, you introduce complexity, and you also introduce the propensity for human error if it's a human process that has to be managed. So by automating this correctly, hopefully we can alleviate all that or reduce the time and cost to deploy a new application or replicate an application in the data center. In terms of VM awareness capabilities, there are actually multiple technologies in the industry being given to the market by many vendors that solve the same type of problem or seek to solve the same type of problem. In terms of major categories, in ways of linking the network to the virtualized host in the network, there are two major categories, and those would be in-band signaling and out-of-band signaling. If we look at the in-band signaling side, there's been quite a bit of work going on for the last few years, actually, around standards in the IEEE space to provide in-band signaling between the host machine, whether it be a standalone server running an OS or whether it is a virtualized platform talking to an upstream switch, around certain protocols and packet formats. So two of the most common formats would be 802.1br and 802.1qbg. Both of those are in-band signaling methods that implement new frame types and header formats, and also require additional new supporting protocols on the VM and on the top-of-rack switch in order to provide this in-band signaling capability to provide VM awareness or workload awareness in the network. The third category would be an out-of-band or sideband signaling mechanism, and these are typically API-based and leverage communications between either a platform, whether it be a device itself or a middleware, to the virtualization platform management console. So, for example, in the VMware context, which we're looking at here, would be vCenter within a vSphere environment. These API-based mechanisms have their own advantages and differ slightly from the in-band mechanisms. What you'll notice is that various vendors have aligned themselves with various technology strategies. Most notably, 802.1br was initially largely proposed and propagated by Cisco, while 802.1qbg, 802.1qbg's largest proponent was HP for a long time. But for the most part, those in-band signaling methods have sort of slowed in their adoption rate and henceforth their development. They're still available, but we find that most of those in-band signaling methods have slowed down in terms of adoption or interest. And the reason for that, as we'll see later, is that the API-based mechanisms lend themselves to certain advantages and also fit certain models that are more forthcoming with upcoming technologies such as software-defined networks. So we'll look at these network integration models. So if we set aside the in-band methods for now and look at just the out-of-band methods or sideband methods, there are really two models that can be used in the out-of-band method of integration between network and virtual machine workloads. The first would be the direct method, in which the top-of-rack devices or the network devices themselves speak directly to the virtualization platform management console. So, for example, VMware's vCenter for vSphere. There are vendors in the industry that do this. When there is a change in the virtual machine configuration, moving a workload from one top-of-rack switch to another, the top-of-rack devices or switches within the network actually communicate with the VM management console or vCenter in this particular case. And that is one model. I won't go into the details of the pros and cons of that model because that's not particularly the model we use in our solution, but I will talk about the other model and the benefits to that particular model itself. The other model would be a middleware-based approach, in which the top-of-rack switches and network devices talk to a middleware-based component, a platform component, which consolidates their requests, changes, and configuration management, and then that itself, that middleware interfaces upstream or northbound to the VMware management platform or a vCenter console in this particular case, using a defined set of APIs. So here we have, from the middleware perspective, we have a southbound set of APIs to the network devices, and we have a northbound set of APIs to the virtualization platform management component. And from a network device perspective, we are abstracting the virtualization environment from the network component through northbound APIs to that middleware. The nice thing about this middleware-based approach is it has several advantages. The first is it's a highly scalable model. Because we are consolidating requests through this middleware, we can scale this to extremely large proportions. It tends to be extremely fast. It doesn't place a load on the virtualization management platform. So the requests for changes or requests for policies, the interaction from the different network components, which could potentially be hundreds or if not thousands of nodes, doesn't hit the virtualization management platform. So you're not hitting vCenter with those particular API requests. The nice thing about it, too, is because we're abstracting the network from the virtualization component, we can mix those components and have full integration between them fairly easily, meaning that that middleware could be a routing mechanism to provide these messages to and from the top-of-rack switches to one or more multiple types of hypervisor management platforms. So if you end up in an environment where you might have mixed hypervisors, or you're looking at a dual hypervisor strategy, or if you even want to be able to migrate from one hypervisor to another in the future, you can do that with the middleware-based model fairly easily because of that abstraction behind that platform. So in theory, you could actually have, because of that abstraction, you could have this middleware providing VM awareness for both a VMware environment as well as a Microsoft Hyper-V environment simultaneously, leveraging the same policies for all of the top-of-rack switches and minimizing the amount of change that's required in order to interface with dual systems at the same time. The other benefit of this middleware-based approach is it uses, as you can see, a very similar model to what is proposed in an SDN controller model. Essentially, that middleware is a controller. And what we are actually doing is defining the logical configuration of network elements, in this case the top-of-rack switches, to match the logical requirements needed to deploy that application. And if we talk about matching or basically reconciling the difference between logical requirements in the network and physical topology of the network, that is the essence of software-defined networking. So the nice thing about this is we've already begun to wander down the road of the model behind SDN networking. Right? Basically, with software-defined networks, what we're doing is we're using a controller to help reconcile the requirements of what we need from a logical topology to the physical topology, and that's exactly what this middleware-based solution architecture does. So we've already moved down that road, and actually makes evolution towards an SDN model much easier as we move towards it, in order to expand the capabilities of that particular network environment. So with that quick look in terms of network to virtual machine integration and understanding what it is we're trying to accomplish in the different types of models, let's jump to polling question number 2 real quick and get some more feedback from the audience.
Thanks, Ian. Ian talked about the whole purpose of this webinar was to really help people understand how to deploy applications more effectively, especially in larger environments. So what we're trying to find out now is how many VMs are you currently managing? How many are you deploying? Let us know if it's a small number less than 50, if it's 50 to 100, 150 to 500, 500 to 1,000, or more than 1,000. So we're just trying to get a sense of the scale of your environment, and that'll help Ian tailor the presentation. And I warned you guys and I explained to you guys that Ian has this way of taking very complex topics and making them very digestible and very understandable, and that's why we love him to do these webinars, so that's great. We'll give you all another 5 seconds to vote, so please cast your vote, and then we'll show you guys where you stand relative to each other in terms of scale. All right, let's go ahead and share it, and as you can see, about 40+% less than 50, and then just kind of a sliding scale, 29%, 50 to 150, and then kind of an even break between 150 to 500 and 500 to 1,000. So some pretty good environments in there, and that'll help Ian as he goes forward. So Ian, continue on.
Yeah, thanks for the response. And the reason I asked that question is because for the larger environments, we have a lot of VMs. People automatically see the benefits. They say, oh, well, if I can automate this and I have to roll out another VM, or I have to roll out another 50 VMs, I can reduce complexity, and the benefits are obvious. What's not as obvious is that even in the smaller environments, even when you only have about 50 virtual machines, tying it into the network infrastructure removes one level of isolation from one of the resources you have to manage and maintain in order to roll out a service. And the benefit to this is that it's less time spent running monotonous processes of trying to make sure that the configs are in place where they need to be, typically manually, in order to make sure that you can now provision that VM where you need to. The alternative is typically, if you don't have that level of customization for services, is to run a generic template in your network that allows applications to be wherever they are. But as you move forward in terms of security, quality of service, and performance, having that ability to tailor the particular port characteristics and network characteristics to that particular application has a lot of advantages. But you want to do that at the same time. While you're doing that, you want to reduce the complexity and the overhead required to do so. And having that level of network integration into VM awareness, it gives you that capability. So it allows you to automate that, reduce the propensity for human error, as well as gain that level of customizability per application without introducing any additional complexity.
Hey, Ian, it looks like your screen stopped sharing for some reason. So can you try just stopping and starting the sharing again, just to make sure it comes back? It does that coming back from polls every once in a blue moon, so I'm not sure what happened there.
Are you seeing the agenda slide now?
No, I'm not, and I'm not sure what the audience is seeing.
How about? Okay. Any better?
What I might do is see if I can take control and then give it back to you and just see if that does anything. Oh, there it is. There it goes. It's
Okay,
good.
there
It's
we
up.
go. Right, great.
Thank you.
Okay, so and that's okay because as I was doing my narrative about the complexity even in smaller environments, there are actually no slides for that, so we're okay. So we haven't really lost any spots there. For this next section, let me talk about Huawei's nCenter. So I talked about the different integration models, why we want to integrate these into VM awareness, and I'll talk about how we do that with our particular solution. So some highlights about Huawei nCenter. Huawei nCenter is our middleware, quote-unquote, controller-based model for VM integration to provide VM awareness into the network infrastructure. It leverages the VM Platform Manager's APIs, and I use VM Platform Manager generically here, but specifically what I'm talking about is VMware's vCenter VM Manager component within the vSphere solution or platform using APIs. The reason I use a generic term here in terms of VM Platform Manager is because nCenter is also being designed to support other virtualization platforms. So you'll see forthcoming support and the ability to support other environments such as maybe Microsoft Hyper-V or even our own Fusion Sphere hypervisor platform. But either way, the key is that it actually leverages an API into the Virtual Machine Platform Manager, and in this case, vCenter in the context of VMware. In terms of performance, nCenter is extremely scalable and high performance. It supports up to 1,000 virtual machine changes per second. So in terms of scalability, and this is well exceeding the window of even the largest installations, we're able to support virtual machine add, moves, changes, and vMotions of up to 1,000 VMs per second in a given environment that leverages nCenter. So in terms of scalability and performance, again, that's the nice thing about this middleware controller-based platform is by abstracting the network from the virtualization control platform, we can scale this extremely well in terms of both performance and larger scalability. Moving forward, you'll see some additional hypervisor support, as I mentioned earlier, particularly for Microsoft Hyper-V. We are a Microsoft systems partner, as well as for Huawei's Fusion Sphere component. Right now, nCenter itself is a middleware component and part of Huawei's eSite network management system. So nCenter is actually a component within eSite, and it is a key component. But as we move forward, what you'll see is that this functionality within nCenter and nCenter itself will evolve to become a more will evolve to become a core component and core capability within our Agile controller, which is our SDN controller, and particularly for its data center functionality or data center capabilities. So again, if we go back to the middleware model and how it maps very cleanly to the SDN model, that is the natural evolution for nCenter's existence as we move away from traditional static networks and more towards automated SDN networks. We will be moving that nCenter component into that SDN controller, providing a much smoother migration for customers who want to go from their existing environment to a VMware environment, and then eventually move from a VMware integrated environment to an SDN environment. So that in everything we design, particularly in the data center, we try to provide a smooth evolution from where you are today to where you want to be tomorrow to where you need to be 5 years from now. Trying to keep that vision in place that there are no greenfield networks, that we all have to live with what's in place, and the changes we make today may have to be changed again tomorrow, but that those changes need to be risk managed and done smoothly as an evolutionary process, and that's all built into our architectural approach. So let's take a look at how nCenter itself actually works and what the mechanism is behind it when things actually happen in the network. So typically, this mechanism of VM integration is going to be invoked whenever we have a virtual machine add, move, or change or delete. So if I'm adding a new workload or moving a workload is when I would actually invoke these APIs and the mechanism within nCenter to integrate the network into our compute and storage resource provisioning through vCenter. Let's take a look at what happens when I do a vMotion in a data center network. So when I do a vMotion, I would initiate that vMotion from VMware's management platform, vCenter. So in vCenter, I would say that I'm going to move one particular VM workload to another particular physical server, so from physical server A to physical server B. And that physical server could either reside in the same data center, it could be in the same rack, could be in a different rack, could even reside in a physically different data center depending on my architecture and my connectivity, but it could be in a redundant data center, which we'll talk about later in one of our customer case studies. But either way, when I initiate that vMotion, essentially what happens is VMware's vCenter will initiate the vMotion with the virtual machine and the physical server. As it does that, as the migration initiates, vCenter is integrated and is aware of nCenter. nCenter and vCenter can talk via APIs, and vCenter automatically notifies program clients, basically clients that it has been notified that are watching for changes. So vCenter will notify nCenter via these APIs as the migration initiates. So while it is simultaneously preparing to do the migration, it will notify nCenter. Based on the API notification, what nCenter will do is it will look at the topology, look at where physical server A is, the source physical server where the workload is today. Based on a signaling from vCenter, it will know, hey, it's moving to this particular destination physical server, which is on this particular top of rack. So we'll actually reference it, find the destination top of rack, and notify that destination top of rack switch of an impending vMotion related change. That, hey, there's a change coming, you need to update your configuration for a particular port because you're going to have a new machine being provisioned on that particular port soon. So nCenter will notify the top of rack switch. What happens next is that particular destination top of rack switch, now being notified of the pending change, requests the required configuration from nCenter. So we'll actually send a message requesting updated policy from nCenter saying, hey, I know about this particular change coming that you notified me of. Please send me the related policies or configurations that I need to apply in order to accommodate the pending vMotion or pending change in the environment. nCenter receives that request and actually sends all the configuration-related policies based on a template that has been mapped to that particular virtual machine profile back to the switch. And that top-of-rack switch applies that set of policies and configuration to the current active configuration. Now, when the vMotion is complete, when that new workload is moved over to the destination switch, that process is being monitored by vCenter. vCenter will again notify nCenter of the completion of that vMotion via APIs. So the vMotion is complete. We now have that workload in the new destination server connected to the destination switch, which has already applied the required set of policies and configs. And vCenter will notify nCenter that the vMotion is complete, and nCenter will do the cleanup on the original source switch where the workload originated from. In this particular case, it will either return the associated ports or network config to a set of default templates that have been defined by the administrator, or set it up for a new set of required policies if there's an incoming workload or incoming application coming on that port instead. And it's a very simple mechanism, very straightforward, which is why it can scale to levels of performance that we're seeing that we mentioned earlier. So now that we understand how nCenter works, hopefully the audience understands a little bit more about nCenter and our strategy to move towards software-defined networks and provide an evolutionary path with VM awareness as a core functionality to it. Let's step into polling question number 3 real quick.
Excellent, excellent. Okay, so the final poll is really just an opportunity for us to get a feeling for your time frame. So the question is, what's your time frame for leveraging what Ian's been talking about, which is kind of a network integration of virtual machine awareness? And let us know if you're already doing something like this, or if you plan on doing it within the next 6 months, within the next 2 years, if you think it's more than 2 years out, or if you think you have no plans ever to do this. So please, this is our final poll. Please cast a vote. We really want to get an understanding of what the audience is thinking here, and we'd love to share it with your peers. So let's go ahead and vote, and we'll share it with you just in a minute. Also, one more reminder as you guys are voting to please keep your questions coming. We've gotten a couple of good ones so far, so keep your questions coming in, and we will address those all at the end of the presentation. So we'll give you another 5 seconds to vote, and then we'll share the results. All right, let's share it. So it looks like the vast majority of you are within the 6-month to 2-year window, kind of an even balance of a few of you that have already deployed and another handful that expect to do it within the next 6 months, and then just a small percentage that have no plans whatsoever. So that's useful. Ian, why don't you take us home?
Great, thanks. Okay, let's move on. So let's talk about a quick case study. And Nick, are you seeing the slides? Are they looking okay?
I'm not.
Okay.
I'm trying to give it back to you, see if that helps.
Hold on, I can just stop and start again. That seems to work. There we go.
GoToWebinar seems a little glitchy for us today. I'm not quite sure why, but I'll let you know as soon as we can see your slides. There it is. Got it. Thank you.
Great. All right, so let's go into a quick case study. I'll discuss the case study. I didn't have a whole lot of time to put together some nice graphics for the case study, but we can get into the details of it. Specifically, this concerns an educational institution in Asia Pacific, one of our customers. So this nCenter component that we're talking about, which is part of eSite, has been around for quite a while. Actually, eSite is a fairly mature NMS platform, and nCenter itself has been shipping and available globally for quite some time, which is beginning to introduce it into the U.S. market, but has actually been deployed in other areas of the world. So in this particular case, we have an educational institution, a university in Asia Pacific theater. They were using VMware for virtualization, obviously in order to maximize resource utilization and to gain the benefits of being able to roll out applications and clone them very quickly. In their particular instance, they had a setup where they have a campus connected by fiber, so they have dual data centers on a campus, and they can treat both of those data centers as a unified resource pool. They have extremely quick connectivity on them on this particular campus network, and they can treat it as one resource pool. The nice thing about it is they can treat it as an individual pool, but because of this ability to move workloads between them, they can also treat them as disaster recovery within the campus context, so that if they lose a data center, they can actually recover those services and demotion those services to the alternate data center, or at least replicate them in that alternate data center to recover those services to provide some continuity. Prior to integrating the network into VM awareness, adds, moves, and deletions for VMs for them took anywhere between 30 to 60 minutes because of the manual process involved of communicating between the platform teams and the network team. And in order to open a ticket after creating a particular VM instance and finding a server to allocate it to, they had to step through a separate serialized process of getting the network team to provision the ports required in order to match that particular application. And the way that was done was using templates, but largely by a manual process. So someone had to take ownership of the ticket, go out, make sure the network port was provisioned safely before that application could be fully provisioned on the new port. And then someone had to go out and deprovision that other port manually. And I think a lot of our customers who aren't yet using VM integration are stuck sort of in this rut where they still have staff having to go out there and manually provision and deprovision ports in order to assure that things can move. Post VMware integration with nCenter, virtual machines, moves, adds, and deletions take less than 30 seconds. Essentially, the request comes in for a new VM, vCenter handles it, and it gets pushed out to the network. And the only step that really is introduced by manual processes is manual verification. Once the process is done, a network administrator just checks to make sure everything is okay. And because it's highly automated and repeatable based on templates and profiles, it's extremely reliable with a very low rate of error. So this allows them to offload their staff from that mundane process of provisioning ports to actually focusing on bigger problems within the IT environment and allowing the network infrastructure to adapt and be treated as a resource in a particular environment. Nice thing about this is a workload can be replicated and move faster for near real-time service recovery. So not only can they just roll out new services where they need them in the network, but they can move services from data center 1 to data center 2 as needed as resources become available. But also, if something happens to one particular data center, they can fairly rapidly shift those applications over in near real time. So not only have they gained the ability to treat the network as a resource, but they now have the ability to treat their unified resource as an environment that has an emergency disaster recovery capability with some level of service continuity within that campus. Let's discuss what we're doing at VMworld. So this year, Huawei is a 2014 VMworld USA sponsor. We are a bronze sponsor. We will be in San Francisco next week from August 24th to 28th. You're welcome to come visit us at booth 641. On site, we will be displaying some of our products and solutions. We will be displaying nCenter. We'll have a demonstration video running on nCenter. We'll have experts on hand to discuss nCenter as well as eSite and our forthcoming Agile controller. We will also have and everyone likes hardware, so we'll actually have a Cloud Engine, our newest Cloud Engine platform there, the Cloud Engine 7850 top-of-rack switch, which is our high-density 40 gig, 10 gig switch. It is a 32 by 40 gig platform, which can also break out each of the 40 gig interfaces to 4 by 10 gig, giving you 128 gig 128 10-gig interfaces on a single platform. We'll also have our Cloud Engine 12804, which is our 4-slot core data center core switch. And we'll also be displaying Huawei's latest VMware certified server and storage platforms. While our server and storage platforms are widely deployed around the world, most of our customers in the US aren't very familiar with our server and storage offerings, and we'll be displaying those at VMworld to show you what our product portfolio looks like. And it's a fairly complete product portfolio in terms of storage, compute, and networks. We'll also have some booth giveaways, and we'll also be announcing at VMworld for a limited time in order to promote around our VMworld presence and our VMworld partnership. We're providing a promotional bundle pricing on our latest top-of-rack, low-density top-of-rack switcher, the 6810 top-of-rack switch, which is our 10-gig switch. The interesting thing about the CE or Cloud Engine 6810 is that this particular switch can operate in a standalone mode, so it can be a standard Ethernet switch for L2 or L3, but it can also operate using what we call our SVF, or Super Virtualized Fabric capability, where it can become a node off of an upstream switch. So if you're running, for example, a Cloud Engine 7850 or a Cloud Engine 6850 or a Cloud Engine 12800, you can run the 6810 as a node off the upstream switch, being fully managed and configured from that upstream switch. So in essence, that 6810 would look like a line card running off of that upstream switch. There are other vendors that offer similar solutions to this, for unified management and configuration. The difference in our solution is that the 6810 can operate as a standalone switch for L2 or L3, can operate in this slave mode, if you will, but also provides local switching. So in some of the other industry solutions, this type of configuration requires that all switching happen on the upstream switch. In our particular solution, in the 6810, we can provide localized switching so that traffic doesn't have to move upstream, which tends to be a little more efficient with modern data center traffic patterns, particularly in virtualized environments where traffic would be moving within a rack heavily, potentially, or within adjacent racks, essentially across a single top-of-rack switch, so that local switching capability is there. So the nice thing about the way that's designed is you can deploy the 6810 using the bundle pricing as a top-of-rack switch just to try one of our platforms, and then eventually migrate to either using it as SVF in an SVF-capable environment as a module off of an upstream switch, and use that as an introduction into a VMware integrated cloud fabric infrastructure, and eventually into a software-defined environment. To find out more about this and other solutions that we have, or to find out more about our product portfolio, I'd like to welcome everyone to come visit us at our US website, which is www.huaweienterpriseusa.com. There you can find more info on the nCenter solution, as well as many other solutions, including our networking, storage, and compute solutions. You can use that website to locate a Huawei partner or a VAR within the US, and you can contact Huawei sales through that website. If you're looking for more global information on our wider product portfolio, including our cellular component and our devices components, you can visit us at www.huawei.com, which is our global site. There you can find out more about our global, wider portfolio, global case studies, customers from different theaters around the world, and find product and solutions documentation. So you'll find our user guides and deployment guides and white papers on the global site. And again, I also welcome you to stop by our booth, booth number 641 at VMworld, and come by and say hi. I will be there along with many of our experts who would be glad to meet you and answer any of your questions. If you have any questions, you can also email us at huaweiinfo@huawei.com or call 855-472-9656, and we'll be able to route your call to the appropriate expert to answer your questions or put you in touch with someone in sales. I want to thank everyone for your time and attention today. I think next we'll spend a few minutes going through Q&A. So if you have any questions, please feel free to type them up and send them over, and I'll answer them as much as I can.
Ian, fantastic, and we do have a handful of questions, so we appreciate everybody's participation. The first one is, how do I get a demo of Huawei's nCenter solution?
So there's a couple of ways. The easiest way, if you happen to be in the Bay Area, is to stop by our booth at VMworld. We will be showing it there. If not, if you want a recorded demo, if a video demo of how it works is good enough, you can go to our global site, and under eSite in our products and nCenter, you'll be able to find the video of the platform and how it works. If you'd like a more customized demo in person, or a demo copy that you can install and run just to poke around in, best method there would be to get in touch with our U.S. office at the number here, 855-472-9656, and request a demo if you'd like to see a live demo or get a copy of the demo software.
Excellent, excellent. This next one, I think, is from one of the VARs that's on the webinar. It says, how can I become a Huawei partner? And I'll go ahead and answer that. If you look at the website that we have listed up there, the Huawei Enterprise USA site, there's a special tab on the top-level navigation for partners. You can apply to be a partner there, and the approval process usually takes less than a day, so it's very easy to become a partner. And if you become a partner, we have online training, both sales and SE training that's available. We have ability to do deal registration, price lists. There's all kinds of protected content that's specific for our VAR community. So definitely a lot of good reason to do that, and the website is the way that you accomplish that. Here's one that I think you might like. It says, how large can Huawei's design scale? What have you done in real-world customer environments? You talked about scaling earlier. They're just kind of wondering how big can this thing go?
So, yeah, so the interesting thing is, in terms of scale, so we talk about the network infrastructure, I would classify it as extremely large in the thousands of nodes. And the reason I can say that is we have deployed the same type of architectures and platforms, so in this particular case, the Cloud Fabric network architecture and Cloud Engine switches in internet cloud provider environments. So environments like Tencent and Alibaba, which I'm sure you've probably heard of, some of the largest cloud providers in the world operating out of China, are running our platforms in their data centers to support their operations. So we're looking at some of the largest cloud environments in the world, comparable to some of the largest enterprises in the world, scaling up to hundreds and bordering on thousands of network devices. So it is. All of this is designed to be extremely, extremely scalable. And the interesting thing is that it's not only designed to be scalable, but it's designed to be consistent as you scale, so that you don't change any of the fundamental operational methods, and you don't change any of the underlying topological designs, so that everything remains consistent and scales elastically outwards. So you can basically design any network from 2 core switches and 2 top-of-rack switches with just a handful of servers, all the way up to literally hundreds of thousands of servers.
Excellent, excellent. This question's a little bit off the topic of this webinar, but you might just be able to provide a high level, and then we can point them to the website for more info. The question is, can you please provide some more specs on the Huawei Cloud Engine switches? And just kind of give an overview where those fit in the overall portfolio of switching and some of the specs around those, if possible.
Sure. I'll give a quick high-level one, and again, that's true. It's a little bit out of scope, but you can get all the information you need at the Huawei.com site. But in terms of data center switches, if we're looking in the data center, which is my particular area of expertise, there are typically 2 types of switches. We're going to have the modular core type switch, which can be used for core or end of row, and sometimes people even use them for top of rack. But you're going to have these modular platforms. Our large, what we call big iron modular platform is Cloud Engine 12800. Cloud Engine 12800 comes in various configurations, from a 4-slot to an 8-slot to a 16-slot chassis, delivering extremely high density 10, 40, and 100 gig E. So it's purely designed to be a core switch. That switch is actually being used in data center cores, but it's also being used, interestingly enough, as campus core. So we do have customers using it as a campus core switch, where they're trying to keep the core pure, not running any particular types of services in the core, and they're just moving packets from A to B, but they need high-density interfaces at 10, 40, and 100 gig. So while it is primarily designed as a data center switch, we do have customers using it as a core switch. But that's the big iron platform. The top-of-rack platforms, we have 3 flavors in fixed configuration top-of-rack platforms. So if we say that one category is modular config and the other category is fixed config top-of-rack, in our fixed config top-of-rack categories, we have our 5850s, which are our gig E switches. So those provide gig E connectivity to a host with 10 gig E uplinks and 4 gig E uplinks. We have our 6800 series, which consists of the 6850 and 6810 that I mentioned earlier, which are 10 gig E switches. They're designed to provide 10 gig E connectivity to hosts and 40 gig E connectivity northbound to the upstream switch. And we have our newest switch, the 7850, which is a high-density 40 gig E switch. That can also be broken down to an extremely high-density 10 gig switch, but is configured as a 32 by 40 gig E switch. So in terms of capabilities, in specifics in terms of forwarding, table sizes, MAC table sizes, best thing would be to hit the website and pull down the data sheets for those to get more specifics on those.
Excellent, excellent overview. The next question is, you mentioned the middleware-based integration. I thought I heard you say we only support VMware currently. What is the time frame for adding support for additional hypervisors, and what's the development priority across the other hypervisors?
Okay, and that's a great question. So I would say right now, so Huawei itself, we also provide, if you go to our website, you'll see in our product portfolio, we provide a virtualization platform called FusionSphere. FusionSphere consists of our virtualization, including our own hypervisor and virtualization management platform. That is primarily designed for carriers and cloud providers who are looking for a one-stop solution across the board. And we do have some enterprise customers in the various theaters looking at it as well as an alternative. So in terms of priority, our integration priorities are, yes, today we only support VMware. We will be adding Microsoft Hyper-V. We are a large Microsoft partner. We will obviously need to add FusionSphere. I would place Hyper-V and FusionSphere at the same level of priority. And past that, I would say that we'd be looking at Citrix Zen, which is the next largest offering in the market. So right now, I would probably say those are loose priorities. I can confidently say Microsoft Hyper-V, FusionSphere are next. And then beyond that, it would be more market and customer driven between Citrix Zen and potentially we're seeing a shift in the market towards some of the Linux-based solutions. Not so much in the enterprise, but on the cloud provider side, we're seeing a bit of a shift towards KVM and Linux containers such as Docker. So if the enterprise starts to go that way and we see critical mass in that space, we may be able to integrate that. But right now, I can say with a higher degree of certainty, Hyper-V and FusionSphere, and then after that, everything else, which is still up for grabs depending on customer and market demand.
Excellent, excellent. And we have a couple more. One is, what are Huawei's major competitors in the software-defined networking space, and what are Huawei's advantages against them?
That's good. That's a very good question. So in the software-defined networking space, if you're a networking professional, everybody's an SDN today, right? Everybody has some type of SDN solution. So we compete in terms of being able to provide software-defined networking. Our competitors could be everybody from Cisco to HP to Dell to even VMware itself, right, through their NSX offering. What are Huawei's advantages? We're open to an ecosystem of integration and understand that open options as well as standards are probably the best option for our customers in terms of longevity of the data center. So if you look at what we're doing, even with our SDN controller and with nCenter, is we're providing options to integrate into multiple other platforms because we understand that no two network environments, and particularly data centers, are alike. But without those open options, evolution is fairly limited. So one of our advantages is that this open approach to SDN and integrating with third-party platforms as the controller, aside from offering our own controller, is not a threat to us. It's actually an opportunity for us. So by embracing that capability and providing our customers with the most flexibility in terms of tailoring their environment and integrating with those other third parties, I think we provide a tremendous advantage in that space. It's a little bit of a different approach from what you might see from other vendors. So we're not aligning with one particular technology. In other words, we're not building a hammer and trying to propose that every problem looks like a nail. We're building a toolbox and understanding that you might be, you may want to use certain tools from our toolbox, but you might want to use someone else's hammer or someone else's saw or screwdriver, and we need to be able to work together with that in order to provide the most value for our customer.
Outstanding. And one last question has to do with the integration methods that you were talking about before. Can you just explain a little bit more about the inbound versus out-of-band, and what is Huawei's recommendation relative to the integration methods?
Right. So the inbound is, as I mentioned earlier, it was a couple of efforts by certain network vendors to provide signaling between the host and the network in order to be able to identify a particular virtual machine and apply policy and configuration to that virtual machine and its traffic streams. The benefit to this was that by being in-band, it has a great level of granularity, but largely, by and large, the in-band methods have pretty much died off. You don't hear the vendors who have been pushing them even talking about them much today. In fact, in a lot of cases, they've actually shifted their strategies. So if we look at, for example, Cisco, early on they were proposing an in-band strategy. The in-band strategy hasn't made a lot of progress, and because of the play towards SDN is naturally an out-of-band mechanism. So rather than trying to promote new protocols and new frame headers, to accomplish a subset of what a software-defined data center should do, I think most of the industry has rallied around just embracing SDN and moving towards an out-of-band method with a controller. So my advice to the general market would be to probably go with a middleware-based, controller-based approach, because VM awareness is just one component of an SDN data center or software-defined data center. The ability to move policy and reconfigure the network based on VM awareness is just going to be one tiny facet of a software-defined data center. You're going to have other capabilities and other facets within that controller and within that data center you're going to want to do via SDN. You want to be able to maintain consistency on how you apply those mechanisms, whether it's just VM awareness or whether it's traffic engineering or whether it's other capabilities in SDN later on. So I would shift towards that paradigm. That would be my advice.
Outstanding. Well, that pretty much exhausts all of our questions for today. So I'd like to give a huge thank you to Ian for the phenomenal job presenting on this topic. And remember, as Ian said, if anybody's in the Bay Area and you're in the area to come up to visit at the VMworld event next week, Ian will be there. So he'd love to meet you in person and answer any other questions that you may have. Just to give you a heads up, we have a couple more webinars coming up over the next few weeks. We actually have one tomorrow on WLAN. Specifically talking about implementation of 802.11ac and kind of the evolution of that standard. And then next week we're doing one on application acceleration, PCIe card. So if you have time, we'd love you to attend those webinars. Be on the lookout for the invite to the PCIe one that'll be going out today. And hopefully we'll see some of you tomorrow on the WLAN one. So Ian, thanks again for your time, and thanks again to everybody for their attention and willingness to participate with us today.
Great. Thank you, everyone, for joining us.